is the last example of 10.1. Let's go ahead and read it and give it a shot. It says, high levels of cholesterol in the blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki, meaning Helsinki, Finland, I believe, heart study recruited middle-aged men with high cholesterol, but no history of other serious medical problems to investigate this question. The volunteer subjects, okay, that's an important point, okay, were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil, if that's even how you say it, to reduce their cholesterol levels, and a control group of 2,030 men took a placebo. It says during the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Is this difference statistically significant at the alpha equals 0.01 significance level? Okay, just a couple remarks right here. Usually in any type of medical study, their alpha is going to be lower. Okay, they need much more proof. It needs to be much more further away from the mean than in other types of studies because it's medical. All right, it has more impact on people. All right, so let me just kind of note, and sometimes when you're making a statement, so let's go through a process here. So one statement is going to be our hypotheses. All right, let me define my groups here. We'll say group 1 is middle-aged men middle-aged men with high cholesterol taking gemfibrozil, and the group 2 would be middle-aged men with high cholesterol taking placebo. So let's define our hypotheses. All right, our null and our alternative hypotheses. All right. So this is going to be a proportion because it's 56 out of the 2051 and 84 out of the 2030. Okay. The real question comes to is, will using a drug lower blood cholesterol? To lower blood cholesterol reduce heart attacks. So we would expect, all right, that the people in group 1, at least the sample in group 1, would have a lower proportion of heart attacks than group 2. Okay, so my alternative hypothesis is that row 1 would be less than row 2. All right, that's the question I want to answer is there enough evidence to show that? If I want to rewrite that, that would mean that row 1 minus row 2 is less than 0. All right, so what does that make the null? We're going to assume that the true proportions are the same. We can also write that as P1, or row 1 minus row 2 equals 0. So there's the statement. All right, now this is an experiment. So just like it says up here, we don't actually have to check the 10% condition, so we don't have to do the independence condition. All right. But we do have to check the other two conditions. Random. Now, we did not randomly select these men. They volunteered, okay? Or they were recruited in some way. So there's not random selection, okay? But there is random assignment, okay? So I can say the men in the study were randomly assigned to an experimental group. I say an experimental drug group, or a control group. You say, or a placebo control group. All right. And since it's an experiment, you don't have to do a 10% condition. If you did it, they would not take points off. If you did your independent, all right, you wouldn't have, they would not take points off for that, but you don't technically have to check the independence condition, all right, because it is an experiment. So maybe just for independent, I can say this is an experiment and the 10% condition does not need to be checked or need to be verified. Okay, so that's just a slight twist. And lastly, this condition still has to be checked. So we're going to use normal curves to help us. Right. So we have to say n times p hat 1 has to be greater than or equal to 10. N times 1 minus p hat 1. These are n1, sorry. N1, 1 minus p hat 1 has to be greater than or equal to 10. Remember, group 1 was the drug group. This thing right here stands for the number of successes. All right. So even though having a heart attack, I wouldn't consider that to be a success. That's what we're measuring here. So there's 56 in the drug group that had a heart attack. All right. And if 56 had a heart attack, remember this is gemfibrozil group, all right, and there was 2,051 men in total. That would mean that 1995 did not have a heart attack. These two numbers would add up to the 2,051. All right, so both of those numbers greater than 10, awesome. All right, then we're going to check that N2 p hat 2 is greater than or equal to 10, and N2 1 minus p hat 2 is greater than or equal to 10. So this is the number of successes, okay, or how many people had a heart attack in the placebo group. So that would be 84. That number is greater than 10. All right, so that checks out. All right, and there were 2,030, so if I subtract 2030 minus 84, that's 1946. It's greater than or equal to 10. These two numbers add up to the 2,030. All right, so the conditions are done. So those check out. All right. Next would be my calculations. I like to give the name of the test here. Okay, the data comes from two different samples, or two groups, if you will. So this is we're dealing with proportions. So 2 prop, we're using the z-curve, and this is a hypothesis test. So this is a 2 prop z-test. All right, and they tell me that my alpha is 0.01, my significance level. All right, so we need to calculate the test statistic with a hypothesis test. We have to get the p-value. All right, so the test statistic, which will be z, is going to equal the sample difference, so p hat 1 minus p hat 2, minus the hypothesized value of the difference over that big square root p hat combined, 1 minus p hat combined. All right, times 1 over n1 plus 1 over n2. All right, let's just write out what these things are. P hat 1, okay, that was the drug group, 56 out of the 2051. P hat 2 is the 84 over the 2030. Obviously, when I write it like that, it's going to be real easy to see what N1 is. It's 2051. N2 is 2030. Right? And your p hat combined is going to be the number of successes in both, so 56 plus 84 over 2051 plus 2030. So just writing this stuff down lets the reader know that you're going to plug those numbers into this formula. Okay. And when we do that, let's go ahead and do that by hand. So just like before, I like to actually put those values in, get decimals, and store them. So 56 out of 2051. I'm going to store that as A. So about 2.7% of the drug group had heart attacks. 84 out of 2030. All right, 4.1. So that looks higher, but remember, this is just a sample, and there's natural variability among samples. I'll store that as B. Okay, now I'm going to store this thing as C. Okay, so let's just put it in as a fraction. 56 plus 84 over 2051 plus 2030. Okay. So it reduced it for us. Let's just convert that. If you want to see it as a decimal, convert it to a decimal. Okay. So that's the p hat combined. I'm just going to store that as C. So now let's look at that formula and let's get a value. Okay, so all right, we got our p hat 1, which we call A, minus our p hat 2, which we call B, minus the hypothesized difference, which was 0, square root of p hat C, okay, we call that C, over 1 minus C, okay. 1 minus N1, okay, that was the 2051, plus 1 over the 2030. All that goes underneath the square root. And then just hit enter. Right, so negative 2.47. So that's the test statistic. So on our normal curve, the hypothesized difference is 0. This is a z-curve. Right. And then we're getting a z-value of negative 2.47. Now let's go back up to our alternative. It's a less than, so it's only a one-tailed test. So I just need to find that area. And that area would be the p-value. All right, so we can use our calculator. Let's store this as our z-value, our test statistic. Okay, and then let's do our normal CDF and go from negative infinity up to that z-value with standard normal parameters 0 and 1. Paste. All right, 0.00675. Okay, or sometimes that could be written as 6.75, 1, 2, 3, times 10 to the negative third. Okay, so really small. So we got 2 more steps in our process. We have a decision and then a conclusion. So the decision here, we link it to the p-value and the alpha. So in this case, p-value 0.006. All right, the alpha was 0.01, so that number is less than that number. So the p-value is less than the alpha, so I'm going to reject HL. Last step. We're going to write our conclusion. There is sufficient statistical evidence at the alpha equals 0.01 level to conclude that middle-aged men with high cholesterol but no other serious medical problems taking the drug Gemfibrozil have a lower incidence of heart attack than those men taking no real medication, because a placebo is a sugar pill. Okay, so there's sufficient statistical evidence that this drug does help reduce the chance of heart attack. Now let's check our calculations real quick. Before we did it with a graph. Okay, so let's do it now just with the just calculate instead of graph. So if I go stat, go over to test. Okay, this would be a 2 prop z test, number 6. Okay, it's going to ask me for raw data. All right, so this raw data here, x1, n1, x2, n2. x1 would be 56, number of successes out of the 2051. Our x2 would be the 84 out of 2030. All right, our alternative hypothesis is less than. All right, and now we calculate. This gives a little bit more information here. All right, it tells me here that the test statistic is negative 2.47. That matched. The p-value is 0.00675. That matched. All right, it gave me my p-hat1 and my p-hat2. Okay, those were the numbers we got, and we stored as a and b here for these fractions. And it gave me my p-hat combined of 0.034, and that's what we got when we did this fraction and put it in as a decimal. And then it confirms your sample sizes for you. All right, so everything matches up perfectly in this example. So it gives me confidence that we did it correctly. All right, so I'm going to stop the video there, and it's just the last example here. Then we'll move on to 10.2. Thanks.